Hello students, welcome to School Life YouTube channel. Today's topic is Newton's 3 important laws. So without wasting time, let's quickly start the video and learn. Newton's laws of motion are 3 fundamental principles that describe the relationship between a body and the forces acting upon it. However, since you asked for Newton's 3 important laws, I'll assume you're looking for the 3 laws of motion and 2 additional key concepts often associated with Newton and the law of universal gravitation and the concept of absolute time and space, though the latter isn't exactly a law in the same vein. Here's a detailed explanation. 1. Newton's first law of motion, law of inertia. Newton's first law states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction unless acted upon by an unbalanced external force. This law introduces the concept of inertia, which is the tendency of an object to resist changes in its state of motion. Example: a book lying on a table will remain at rest until a force like a push or pull is applied to it. Similarly, a ball rolling on a frictionless surface will continue to roll indefinitely unless external forces, like friction, slow it down and eventually stop it. 2. Newton's second law of motion. The second law relates the motion of an object to the force acting upon it. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The formula is often expressed as F equals sin ma, where F is the net force, m is the mass, and a is the acceleration. Example: when you push a heavy box, the acceleration of the box depends on how hard you push it, the force applied, and the mass of the box. If you apply a greater force, the box accelerates more. However, if the box is heavier, more mass, it will accelerate less for the same amount of force. 3. Newton's third law of motion. The third law states that for every action, there is an equal and opposite reaction. When 2 objects interact, they apply forces to one another that are equal in magnitude and opposite in direction. This law highlights the reciprocal nature of forces in interactions. Example: when you jump, your legs apply a force to the ground, and the ground applies an equal and opposite force upward, propelling you into the air. Similarly, when a gun is fired, the bullet exerts a force on the gun in the opposite direction of its motion, causing the gun to recoil. 4. Newton's law of universal gravitation. While not one of the 3 laws of motion, Newton's law of universal gravitation is another fundamental principle he introduced. It states that every point mass attracts every other point mass in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The formula is F equals sin g frac m atr squared, where g is the gravitational constant. Example: this law explains why planets orbit the Sun and why objects fall to the ground on Earth. The Earth and the Sun exert gravitational forces on each other, and the Earth exerts a gravitational force on objects on its surface. Conclusion: Newton's laws of motion and his law of universal gravitation laid the groundwork for classical mechanics and have had a profound impact on science and engineering. They describe how objects move and respond to forces, providing a framework that is still widely used today for understanding the physical world. While modern physics has introduced new concepts that extend or modify Newton's ideas, his laws remain fundamental in physics education and application. Let me know in the comments how you liked the video and what topics you would like to see in the next video.